Hello and welcome to my first video build series where I'll be going over the making of this pneumatic engraver. This is Rick Alexander's design, however I've made a few modifications to meet some specifications that I wanted in my engraver. Here is Rick's YouTube channel if you'd like to check it out. If you scroll down all the way to about 7 years ago, you can see he has his own complete build series going over how to make this pneumatic handpiece. He also does a great job of showing how to make one without having any specialized tools. I'm pretty sure he builds, you can build this complete with just a drill press and some files and stuff. But my build series, I'm going to be using all my tools. But like I said, if you want to see his page, here it is, Rick Alexander. He's got a lot of cool stuff on here. I would encourage you to check it out. Right now when I'm engraving, I just use a hammer and chisel. Using these simple tools, I can do engravings and inlays like I've done on this knife handle that I made a few years ago. However, with this hammer and chisel, I have a hard time doing line engraving. So that's why I want to make this pneumatic engraver. I think it'll make it much easier to do line style engravings. The main differences between my design and Rick's is that I will be making my own engraver collets. I didn't feel like purchasing ones off the shelf. They're not inexpensive for kind of, what they're used for, but I decided I could make my own and then spend nothing except kind of sweat equity. So I'm going to make my own engraver collets, and then my other part of the design I changed is the end cap here. I added in a feature that allows me to spin the handle and to any orientation without having to adjust the barrel and sleeve and kind of spring rate and everything. That'll make more sense later on, but for right now, the basics of how this works is that through this hose barb up here, so this hose barb will connect to a compressor that will just cycle air, so it'll just push and pull air. It won't actually compress the air. And then that air goes through the end cap here and then into the cavity that this hammer piston rides in. So that push and pull will move that hammer back and forth, striking the back of the engraver collet, and that is the hammering action. So instead of using a hammer and chisel, I will be using this, air-powered pneumatic engraver. There are quite a few parts that need to be machined here, so in this episode I'll be focusing on machining the barrel. This seems like a good place to start, as every other part attaches to the barrel. As suggested by Rick, I'm going to be starting off with this stainless steel bolt. It has half 20 threads on the one side and an unthreaded section on the other, and that's exactly what I need. So I'll start off by cutting off the head of this bolt, giving me my starting material. The first thing I'm going to machine is this thread relief groove here. So I'm going in on the lathe with a grooving tool to cut that. And now I'm moving out to roughly the final length just to part off as much material as I can. And going with the grooving tool again to cut it off. However, stainless steel is not fun to machine. I chipped an insert, which isn't the end of the world, so I flip it around. However, once I get back to the machining, I chip it almost immediately again. So I didn't want to keep on breaking inserts and went to the bandsaw to cut off the excess material. Going back to the lathe, I then face it off with just a normal turning tool, and we're back up and running. Now that the threads are cut to the final length, I go ahead and put some blue dicum on the unthreaded portion so I can go on the granite block with my height gauge and mark out the overall length. I will not actually machine it on that side, however, because I remembered I need to drill and ream this 0.376 inch diameter hole that the hammer piston will ride in. A spot drill with a center drill. And now I'm switching out to a 5/16 drill just to hog out most of the material. I'm using this drill stop here that I made. It's just a scrap piece of aluminum with a 5/16 hole drilled in it, held on with a clamp. And upon entering the cut, there was so much vibration, the clamp popped off immediately. So I go ahead and put the clamp back on, this time tightening it a lot more. Now that everything is set up again, I can continue drilling out this hole. However, I still hate machining stainless steel. As you can see, my drill bit is getting stuck, and it actually pulls out my drill chuck from the tailstock of my lathe, just causing everything to spin, which is not only dangerous, but kind of annoying. So I decided to stop recording and just focus on the actual drilling of this hole. So as you can see here, I'm still with the 5/16 drill bit, and I'm now all the way to the drill stop. Now that that 5/16 hole is drilled, I am swapping that out for a 9.3 millimeter drill. And this is the pre-drill size for the 0.376 inch hole I'll be reaming later on. Learning from past mistakes, I start drilling the hole first before adding in the drill clamp that I'm setting to the final length here. And I continue on very easily because there's not a lot of stock left to drill out that hole to the 9.3 millimeters. I'm now swapping out the 9.3 millimeter drill for a 0.376 inch diameter reamer. So this reamer goes in and just gets the piece down to the final size. There was a lot of heat buildup in the part as I was doing all the drilling, so I decided to take my compressed air and just blow into the part to cool it down. Even that little bit of heat can cause the internal diameter to expand, meaning when it cools back down to room temperature, the internal diameter could actually be smaller than the 0.376 of an inch I'm reaming out to. So now that the piece is back down to room temperature, I'm going to run the reamer through one more time just to make sure that final inside diameter is the 0.376 of an inch I need. Now I can pull the part out, flip it around so that the threads are now inside of the lathe chuck. Swapping out for just a normal turning tool, I can turn down the barrel to the final length to my scribe line from earlier. The next feature I'll be machining is this 1/4 inch hole. It's actually 0.251 of an inch. It's 1/1000 over a 1/4 of an inch. So I'll start out again by spot drilling with a center drill, then coming in with a 3/32 drill. This will do most of the material removal. Once I'm through with the 3/32 drill, I will come in with a letter C drill. This is the pre-drill size for a 1/4 inch reamer. I'll come in with my 0.251 inch reamer. Once again, cooling down the part just to make sure that there's no material shrink over time as the part cools down, and running the reamer through one last time to make sure the diameter is exactly what I want it to be. Now that those two holes are drilled and reamed, I can take the part off the lathe, and a quick inspection shows that both the holes turned out really well. They both have a great surface finish, and this part is already much lighter than it was before. Now that the work is done in the lathe, I'll be going over to the mill to finish out this part. The first feature I'll be machining on the mill are these 4 vent holes. To get started, I'm going to go ahead and apply some more blue dye gum before marking out where the holes need to be located. I'll be using a 5C collet to hold the barrel in the mill. This is my first time getting to use a 5C collet block, which is a very handy way to take round parts and hold them on the mill. Go ahead and tighten that down, and now I can get this set up on the mill. I'm using a set of parallels to set the height of the 5C collet block. And then as you can see here, I'm using a parallel to align the top of the 5C collet block with the side of the jaws on the vise. That will make the subsequent operations much easier to set up. So I'm going to go ahead now and touch off of the side of the barrel here. I'm using an edge finder and a drill chuck, which is not the typical way you want to do this. However, because these holes are not super critical in location, I'm going to go ahead and get away with this instead of swapping out for a 3/8 R8 collet. I'm just going to use my drill chuck and call it good enough. To align the spot drill where it needs to in the x-axis, I'm just going to do this visually. Now that I picked up the location of the hole, I'm going to go ahead with the center drill and just do an initial spot drill before swapping out for a 3/32 drill bit. This will clear out most of the material from the hole. And I'll follow that up by swapping out to a 1/8 inch drill bit to finish drilling the hole. I'm not actually going all the way through to the other side of the part. This will mean I'll have to do more. I'll have to drill 4 holes instead of just 2 cross holes. However, I'm worried about this little intersection here where the 3/8 hole and the 1/4 inch hole meet. There's a bit of an overlap, so I'm concerned that as the drill bit comes down, it's going to hit that little nub and get kicked off to the side and make the holes not line up perfectly. So it's a little bit more work, but I'm just going to go ahead and drill all 4 holes independently. To set up the mill for the second hole is actually very simple. All I need to do is to rotate the 5C collet block 90 degrees. Make sure once again the top of that block is lined up with the side of the vise jaws. Tighten down the vise jaws, and I'm ready to drill the second hole. So once again, go ahead with the center drill before swapping out to the 3/32 drill, and then finishing out the hole with a 1/8 drill bit. This will then get repeated twice more to finish out all 4 vent holes. The last feature that needs to be machined is this locating nub here. This will just keep the collet clocked correctly that holds the engraver. To do that, I'm once again going to use the 5C collet block, but this time I'll mount it vertically in the mill. I'm getting the collet block roughly trimmed in here with a machinist square, and then I'll go in with a dial indicator and tap the part in so that it's perfectly aligned with the spindle. Now I'll swap out my drill chuck for a 3/8 R8 collet. In this collet, I will put in a dial indicator, which I'll use to pick up that center reamed hole. I don't want to go on the outside of the bolt because that's a uncontrolled feature. However, that inside was a machine feature, and that's where the collet's going to go. So obviously, that's where I want to locate the mill on to make sure that the locating nub and the collet fit up perfectly. I spin the spindle round and round until the dial indicator doesn't move anymore. That means that the spindle is perfectly concentric with the center hole that I drilled and reamed earlier. I will then set my 0 on both the X and Y axis before swapping out the dial indicator for a 3/8 end mill. I'm going to go ahead now and just touch off the top of the part by machining off a couple thousandths of an inch and zeroing my DRO. I will first be clearing off the bulk of material here in front of the locating nub. I just go back and forth doing about a 10,000ths of an inch deep depth of cut each pass. I like to baby my mill, so really 10,000ths of an inch is the deepest depth of cut I'll take. The next part I'm going to machine is this area off to the right of the locating nub. Once again, I'm just going to go down 10,000ths deep depth of cut, and I'll come over to the left side of that locating nub and do the same thing, and that clears out the bulk of the material, and now I can machine that feature to the final dimension. Now that the bulk of the material is removed, I'll go in and machine that locating nub to the final dimensions. I'm going in and I have the Z height locked. I'm just very carefully machining a little bit off of each side until that nub is the final width I want. I can then go ahead, take it out of the 5C collet, just a little bit of cleaning up to remove the blue dicum, and the first part of this pneumatic engraver is done. I'm very happy with how this part turned out. I was a little bit concerned about doing all the different machining, especially going from the lathe to the mill and all the setup that would be involved there. However, this part turned out almost exactly how I wanted it to do. I'm very excited to continue on with this project, and I will see you again in the next episode. Thank you for watching.